This is the Chapter 9, Section 7 notes. Today we are going to be looking at different data sets and determining if they should be a linear function, a quadratic function, or an exponential function. So before we get started, I kind of wanted to go through what each of these should look like. So if you have a linear function, when you graph it, it will always be a line, which means it's straight, arrows on both sides, it's a line. The next is a quadratic. This is what the equation looks like. Y equals ax to the second plus bx plus c. That's what we've been working with all chapter. When you graph them, they're going to be parabolas. They're going to be a U shape. And whenever you have a U-shaped graph, it's always going to be a quadratic function. And the next one is an exponential. This is where you have an exponent somewhere in the equation. So you'll have y equals a times b to the x power. Notice how you're not adding or subtracting anything. It's just a simple multiplication with an exponent. Now, when you graph these will always look like a curve. So our very first three problems are graphing a set of points. Which model is most appropriate for each set? So you just simply start by graphing these points. So over 1 up 3 will be 1, 3, 0, 0, negative 3, 3, negative 1, negative 1, and negative 2, 0. So then you want to connect the points. So you want to graph the points first and then connect them. Okay, so these will be connected in a U shape, and a U-shaped graph ends up being a quadratic function. So I'll label this as quadratic. Then I go on to set B. So 0, 2, so I just go up to 2, negative 1, 4, 1, 1, 2.5. Okay, so this, if I connect them, it doesn't go back up, so this will be my curve. If it's a curve, it'll be an exponential function. And the last one, I'm going to graph negative 1, negative 2, 0, negative 1, 1, 0, and 3, 2. This, if I connect the dots, looks like a very straight line. So this will be a linear function. So I go based off of the shape of the line. So problem number 2 says, okay, I'm going to give you points still, but now I'm not going to graph them. So it's asking, without graphing, how do I know which type of function best models the data? Well, without a graph, the easiest thing to do is to draw a t-chart, x and y, and you're just going to split these points into their x and y components. So I'm going to start with negative 3. So negative 3 on the x, and that's 9 for y. Negative 2 on the x, 5 for y, negative 1 and 1, 0, negative 3, 1, negative 7. Okay? So I want to make sure that the x values go in order. So I want to make sure that they are going from lowest to highest. Okay, so that way I can look at the y values and try and figure out a pattern. So how would I get from 9 to 5? Well, you're going to subtract 4. 5 to 1, subtract 4. 1 to negative 3, subtract 4. Negative 3 to negative 7, subtract 4. If you are adding or subtracting, it's going to be a linear function. So if you were to graph these, it would be a straight line. And that's always if you add or subtract the same exact number every single step. So then I'm going to go to B, and I'm going to do the exact same thing. So I'm going to make a little t-chart off to the side here, x and y. I'll have negative 1, 0.5, 0 and 1, 1 and 2, 2 and 4, 3 and 8. Again, I make sure that my x's are going from the lowest number to the highest number, and then I try and find a pattern. So 0.5 to 1, I could add 0.5, but that wouldn't be the same pattern every single time. So I'm going to multiply by 2. Does that work every single time? Yes, it does. 4 times 2 is 8. Anytime I multiply or divide, it'll be an exponential function. So every time that I find the pattern is a multiplication or division, it'll be an exponential. Okay, for letter C, they actually have the table done for you. So now you're just going to take a look at the y function. So how would I get from 0 to negative 0.25? Well, you could subtract 0.25. Does that work for going from negative 0.25 to negative 1? Well, no, you'd have to subtract 0.75. Negative 1 to negative 2.25, I would subtract negative or 1.25. And the next one, I would have to subtract 1.75. Well, there's not the same number, so it couldn't be linear because I'm not subtracting the same number each time. I'm not multiplying or dividing by the same number each time. So this is where it gets a little bit different. I have to look at the next change. So how would I go from negative 0.25 to negative 0.75? I would subtract 0.5. How would I go from negative 0.75 to negative 1.25? I would subtract 0.5. Now this next one, I could also subtract 0.5 to go from negative 1.25 to negative 1.75. So this is what we call the second change, where I can't look at the pattern from the first set, I have to look at the pattern from the second change. And so this is going to be quadratic. Now it's easily noticed if it's quadratic if this first part isn't adding or subtracting the same number and it's not multiplying or dividing the same number. This one's going to be the different one where all your numbers are different. Okay? If all your numbers are different each time, it'll be a quadratic function, which means when you graph it, it'll end up in a U shape.